battery get? What is your other battery?
All right, so today what we're going to be working on is applications of square root functions. Okay, so it's going to be a lot of plugging things in and using our calculator to kind of help us out. So if you'll take a moment and please read through number 1. All right, so what are we comparing? Distance and time. Now, normally, when we compare distance and time, time is the independent variable and distance is the dependent variable. But in this case, we are given that time is t of x, and that's equal to the square root of distance divided by 9.82. Okay? So in this case, time is your y value, and distance is your x value. Okay? And we're going to talk about the different ways we can solve a problem like this. We're asked to figure out the approximate distance that the marble will travel in 3 seconds. So what are they giving us? What is the 3? Time, which is t of x or y. This is y is equal to 3. All right, so go ahead and go into your y equals. We're going to practice solving this a couple different ways. Go ahead and go into your y equals and type in this equation. All right, and then let's go look at our table. Now, as many of you go to your table, you're going to be starting at low values, right? What are you looking for in your table? Okay, but in terms of this situation, what are we looking for in our table? 3 in which column? The y column. So if you're in your table and you're nowhere close to 3 and you don't want to just sit there and scroll, you can press second, and right over the window button says table set, and you can change your table start value to anything you want. Okay, so it'll jump there automatically. So if you want to go ahead and just type in 80 or 85, something like that, and then go to your table. What conclusion can you draw from looking at your table? Yeah, this marble has to achieve, has to hit 3 seconds between 88 and 89 centimeters. Yeah? Okay, so I would fill in part of your table, maybe just these 2 rows. So we know that 88 We know that 88 gives us a distance of 2.99 centimeters, or sorry, 2.99 seconds, and 89 centimeters gives us a distance of a time of 3.01 seconds. Okay, so what that tells us is that we must hit 3 seconds between 88 and 89 centimeters. So sometimes you're going to be asked to use a table to kind of approximate your solution. You've got to kind of know how to do that. All right, let's look at this graphically. Based on the fact that I know that my table has told me that my answer is going to be between 88 and 89 centimeters, what do I need to adjust on my window from just, say, going to maybe zoom 6? The X what? X max, good, because I know I'm going to need to get up to at least 88 and 89 centimeters, right? So go to your window, and I would try, maybe 100 as your X max, something like that, 110, 115. Okay? I'm going to go ahead and mess with my Y's just a little bit. You do not have to get an answer, but it's going to help give us a prettier picture. What Y value am I concerned with?
Above function. Oh, 3.
3. I'm concerned with a y value of 3. So I'm going to kind of do from -2 to 5. You can kind of just play with that. All right, so there's a picture of my graph. Yeah? Okay, what y value are we interested in? 3. So go into your y equals, and you can add in a horizontal line for y is equal to 3. Everyone okay with that? Okay. Will you please sketch a version of this graph on your paper? You do not need to stress about units or anything like that. Just kind of sketch a picture on your paper. Make sure you please label your axes. So our vertical axis is for time, and that's in seconds. And our horizontal axis is for distance, and that's in centimeters. So would you agree that I'm looking for that intersection point?
Yes.
All right. How do we find that intersection point? Second calc 5 for intersect, and then enter, enter, enter. So what is that intersection point?
88.
Okay, 88.38 comma 3. And what does that tell us?
88.38
Good. After 3 seconds, we have traveled 88.38 centimeters. Okay, how would I solve this algebraically?
3 for y and solve.
All right, so we're going to plug in 3 for t of x. So 3 is equal to the square root of x over 9.82. What would I do from there? Good. So 9 is equal to x over 9.82. Multiply by 9.82, and what do you get? 88.38 centimeters. So just like with inverses and solving equations, I want you to be prepared to solve application problems using all 3 methods: tables, graphs, algebra. All right, let's look at number 2. We're given a gas with density D, capital D, in atoms per cubic centimeters. And we're told that the average distance, little d, between atoms is given by little d equals 3 divided by 4 pi d, all raised to the 1/3 power. The gas in a certain region of space has a density of just 10 atoms per cubic centimeters. Find the average distance between the atoms on that region of space. So what are they giving us? Which d? Which one? Big or small?
Big.
Big. The density is equal to 10 atoms per cubic centimeter. All right, so let's plug that in. All right, can we simplify that denominator? Could I write this as 3 divided by 40 pi? So 1/3 power. All right, will you please go ahead and evaluate that in your calculator?
We have to.
Just try it. Okay, everyone should have gotten one of these two answers. Did you get one of these two answers? Okay, only one of these answers is correct. The bottom one. Why? Good. Why does the 40 pi have to be in parentheses? Yeah. If we look at what we were given 3 divided by all of 40 pi, right? If you leave out that set of parentheses, what your calculator does is does 3 divided by 40 and then multiplies it by pi. Okay? So you've got to be sure if you're given a complicated denominator, you make sure and keep that denominator together. So the correct answer here is 0.288 what? Talking about distance, centimeters. Questions on that one? All right, look at number 3. We are given a formula relating the side length of a metal cube to its mass and its density. Okay? We're given the density of gold and we're given the density of lead. And we want to know how much greater the mass of a cube of gold is than the mass of a cube of lead if they both have a side length of 5. So what is that 5 that we are given? S. All right, and we're going to have to find our mass of gold, and we're going to have to find our mass of lead. So what is the equation I'm going to set up for gold? Good. And what would be the equation I'm going to write for lead? Good. All right. How would we go about solving these? What about our calculator?
Get M alone. Should we get
No, it's not that we're solving for the m they have in common. So we're not going to find the intersection. We are solving each of these individual equations for m. So what could we do to both sides first?
Cube both sides.
Cube both sides. Good. And then multiply by your denominator. So go ahead and find the mass of gold and the mass of lead, please.
Oh, I figured out it's like this thing popped off. And pulled it in.
Yeah. All right, so what is the mass of gold?
2,412.
Yeah. Our mass would be 2,412.5. And what would our mass of the lead be? 1,417.5. Okay, but we're not done. What does our question ask us to do? Yeah, find how much greater. So we should subtract these, and what do we get? 995 what? Grams. Okay? Your units are incredibly important in this section, okay? Because your units convey to me that you understand what you're doing. All right? All right, flip to the back and look at number 4. in fighting a fire, the velocity v of water being pumped into the air is the square root of twice the product of the maximum height and the acceleration due to gravity, 32 feet per second squared. Determine an equation that will give the maximum height as a function of its velocity. So I want you to think back a couple weeks ago to your exponent test. And there was that question on there that had the volume of a cylinder. And I asked you to write an equation for the radius in terms of the volume. And many of you left it as volume is equal to. When you are asked to give a variable in terms of something else, that means you want that variable equal to the other stuff. So here, if we want an equation that will give us the height as a function of the velocity or in terms of the velocity, our goal here is to get height is equal to something. Okay, that's what this as a function of its velocity means. It means that v is going to be the independent variable. Everyone okay with that? Okay, but we do have to start with the information we're given. We're told that the velocity v is the square root. So how could I write that? V equals the square root of twice the product of h and g. So 2hg. What do they tell us that g is? 32. So v is equal to 2h times 32. So v is equal to the square root of 64h. All right, so what would we do next? Good. So v squared is equal to 64h. And then divide by 64. So what that tells me is that h is equal to the volume squared over 64. Everyone okay with that? Okay. I'm going to give you some of the time we have left in class. I would like for you to finish this handout, okay? You're going to complete 4B. Put a star by number 5 and make sure you remind yourself to pay attention to your units. If you do not pay attention to your units in number 5, you will mess it up. Okay? And other than that, I'm going to be available for help and just walking around. We'll come back and do the answers in a minute. No, this is not homework. This is classwork. We'll come back and do the answers in a few minutes. So go ahead and get going. Okay, so now that a lot of you have had a chance to finish through these, let's go ahead and talk about it. For 4B, what did you get?
Yes.
Yes. If you plugged in 75, okay, and you would have gotten 75 squared over 64, that gave you 87.89 feet, which is definitely at least 80 feet. So that should have been a yes. Everyone okay with that? Okay, on 5, what did you have to do? Yeah, convert these to feet. So this would have been 0.25 feet, 0.5 feet, 0.75 feet, and 1 foot. And then give your reflex time. Be careful. If you are given rules for rounding, you must follow them or you will lose points. Okay? I don't care if you feel like you're being more exact. If I ask you to round to the thousandths, you have to round to the thousandths. That's 3 places. If I ask you to round to the hundredths, you have to round to the hundredths. Okay? If you're not given a rule, you need to round to the thousandths. Okay? If you're not given a rule, you're going to round to the thousandths. Number 6, you should have gotten 9.747 feet. And number 7, you should have gotten 196 feet. If you did not put units, that's another place you would have lost points. Okay, so be really careful about that. Questions? All right, let me give you your homework and you can get started.
Solve math, some tape.
Yes.